Hi, good morning. My name is Manikant Reddy. I am studying in Ministry of Aeronautical Engineering, Dundigal. Today, I am presenting my Tech Talk AAT Tech Talk video on the subject of data mining and knowledge discovery. My roll number is 22951A6238. I am from Cybersecurity Section A. So, in this subject of data mining and knowledge discovery, I took a topic called a sentiment classification method of web social media based on multi-dimensional and multi-level modeling. So here, the rise of a social media platform such as Twitter, Facebook, Instagram has led to an explosion of user-generated content. This vast amount of data contains valuable information about public opinions, sentiments, and emotions. Sentiment analysis as or opinion mining is the process of identifying and categorizing sentiments, positive or negative or neutral, from the text images or other media. Traditional sentiment classification methods rely primarily on textual analysis using natural language processing techniques. However, a social media posts are often multimodal in incorporating text, images, videos, and emojis, hashtags, and contextual metadata. A simple text based analysis may fail to capture the full sentiment of a post. Why multidimensional and multi-level modeling? To address these limitations, we propose a multidimensional, multi-level sentiment classification model, which multidimensional modeling integrates multiple data sources like text, images, context for better accuracy. Multi-level analysis analyzes sentiment at different hierarchical levels, word such as word, sentence, and document or post. This method ensures more accurate and context-aware sentiment classification, reducing errors due to sarcasm, slang, and multimodal expression. Second one, multidimensional modeling. Social media posts contain multiple dimensions of data instead of relying only on textual analysis. Our method incorporates textual features like lexicon-based analysis, uses sentiment dictionaries such as SentiWordNet and Affin to assign polarity scores towards TF-IDF, term frequency, inverse document frequency, identifies important words in the text. Word embedding uses deep learning models such as word to vec, glow, and bird to capture contextual word meaning. Negation handling identifies words like not that can invert the sentiment polarity. Visual features object detection identifies objects in an image that might influence sentiment. Example, smile, angry, haze, or disaster scenes. Facial emotion recognition uses convolution neutral neural networks to detect the emotions in human face within images. Color analysis extract dominant colors from images. For example, warm colors indicate positivity, while dark colors may indicate negativity. Contextual features user information analysis, past, post, follower interactions, and user influence to refine sentiment classification. Hashtags and emojis. Hashtags happy or sad, and emojis are mapped to sentiment scores, geolocation, and time analysis evaluates regional trends in sentiment, identifying mood shift in different locations and times. Multi-level sentiment analysis. A model or model performs sentiment analysis at three hierarchical model levels. Word levels analysis. Each word is assigned a sentiment score using sentiment lexicons. Senti word net WAD. Word embeddings but word to capture contextual meaning. Negation handling. Not good should not be classified as positive. Sentence level analysis. Deep learning models LSTMS, CNNS transformer used to predict sentiment at the sentence level. Dependency parsing analysis, grammatical structure to understand relations between the words. Sarcasm detection uses neural networks to recognize sarcastic tones based on the word, order, and context. A model architecture, the proposed sentiment classification system follows the steps. Step 1, data collection. The data collection from the Twitter, Facebook, Instagram, Reddit, YouTube, and YouTube comments. API used Twitter API, Facebook Graph API, Reddit API, and data cleaning removes removes noise, special characters, and stop words. Feature extraction extracts textual, visual, and contextual features as discussed in section 2. Step 3, sentiment classification uses a hybrid deep learning approach. Text sentiment analysis, pre-trained BERT model for word embeddings. Sentiment score calculation using lexicons. Image sentiment analysis. CNN model example for facial expression and object rejection recognition. Sentiment probability mapping based on image features, contextual sentiment analysis. Emoji hashtag mapping to predefined sentiment scores. Location based sentiment trends using geospatial sentiment analysis. Final sentiment decision. Fusion of text, image, and context scores using assemble methods. Random forest XGBoost and experimental results 5.1 dataset Twitter sentiment dataset 1M tweets with sentiment labels positive, negative, neural. Multimodal dataset post with both text and images from Instagram. Evaluation metrics accuracy, precision, recall, F1 score. With the increasing use of social media platforms like Twitter, Facebook, and Instagram, sentiment analysis has become essential for understanding the public opinions, detecting trends, and making informed decisions. Traditional sentiment classification methods often rely on simple text based approaches, which may fail to capture the complexity of emotions expressed in social media. To improve sentiment classification accuracy, multidimensional and multi-level modeling can be employed. This method enhances traditional approaches by considering multiple factors such as multiple dimensions, aspect, textual, visual, and contextual data, multi-level analysis of word, sentence, and document. Architecture of sentiment classification model. The model consists of following components: data collection, extracts, post, comments, images, and metadata from social media platforms. Pre-processing includes tokenization, stop word removal, and stemming. Feature extraction, textual analysis, TF, IDF, word embeddings, visual analysis, CNN-based image sentiment detection, contextual analysis, user behavior, geographical trends. Sentiment classification uses multiple fusion to integrate textual, visual, and contextual features. Deep learning models like BERT, CNN, Altea, SEM, and attention network enhance accuracy. Decision making, the final sentiment score is determined using assemble techniques, random forest, and exhibit. Conclusion: this study presents a multi-dimensional and multi-level sentiment classification model that integrates textual, visual, and contextual data for enhanced sentiments analysis on social media by using deep learning models such as BERT, CNS, and attention networks. The system significantly improves classification accuracy compared to traditional approaches. Future work multilingual sentiment analysis, expanding the model to support multiple languages. Fine grained sentiment category classifying emojis happy, angry, and sad. Instead of just positive or negative integration with social media analysis tools applying MDMLM for real time. So finally, thank you. I hope you understand and I hope you like my presentation. Thank you. Thank you so much. Thank you. Bye.